Welcome back to the chart table. I'm QMC Simpson, and we'll be getting into azimuth of the sun. Now you can see right here on my strip form, I already have some information up there. I have the date, have the bearing of the sun that I got with my azimuth circle, a DR latitude and longitude, and the time I took that site. That time is in zone time. Now, when we go into the Nautical Almanac is all in GMT, so we have to convert that to GMT. Pretty easy. We just take our longitude to find our zone description. So it's like 076, 19, 08. And we're going to make that into one number, and we end up getting 076.318. All right, with that, if this 0.318 was above 0.5, I would bring it into the next time zone, because that 0.5 is 7.5 degrees on the other side of that time zone. You're in the other time zone. But since it's less than, and we're closer to 0.75, we're going to use this time zone. So we're going to take that and divide that by 15, 5. So our zone description is 5. Now, you don't necessarily need the letter designation for this, but me knowing how to do that, I know we're in Romeo, just based off because I live here, and we're in the Western Hemisphere, making this a positive value. Now that we have that, we can go ahead and convert zone time to GMT by just adding 5 hours. So this 09 becomes 14 hours, 30, 15, GMT. Now that we have our GMT time, we can go into the Nautical Almanac now. So the Nautical Almanac is split into days, 3 days per daily page. We're going to find the date for 08, December. Now, as you can see, in the Nautical Almanac, it goes from 0 to 23, covering every hour within a day. We're going to find 14. The 30 and 15, we're going to go to the back of the book into the increments and corrections page. We'll get there in a second. So we're going to find 14, which is 31 degrees, 59.7. Now going to the increments and corrections pages in the back of the book, they're all split off into minutes at the top. We're gonna find 30. So we found 30, and within that table, you got 0 to 59. So it covers everything within that minute, every second within that minute. We have 15 seconds. So we're gonna scroll down, find 15. We got 7 degrees, 33.8. And to find total GHA, all you have to do is add those together. It's always adding. Now this might be simple math for everybody. I always use a calculator to make sure. 59.7 plus 33.8, you get 93.5. Obviously you can have over 60 minutes. So we're going to subtract 60 and add 1 to here, making this 32, or you could have added to the 7, it doesn't matter. So minus 60, our minutes is 33.5. We got 32 plus 7, 39 degrees. So our total GHA is 39 degrees, 33.5 minutes. To find LHA, we're going to take our longitude, and we're either going to add it or subtract it to the GHA. Now, if you're in the Western longitude, the Western Hemisphere, you will subtract. It even tells you on the strip form. If you're Eastern longitude, you would add it. If you get a negative number, you would add 360. So we're going to take our longitude, 076 degrees, 19. We're going to convert that 08 real quick just to make the math easier. 0.1 minutes. We're going to subtract that based off being Western. And go ahead and lock it in. 33.5 minus 19.1, 14.4. And then we have 39 minus 7.6. You get a negative number, negative 3.7, add 360 to it. Basically, once it starts over, once it hits Greenwich and keeps on going, always starts over. So it'll always be a 360. And we got 323 degrees. Make our LHA 323 degrees, 14.4 minutes. Now, we are going to go back to the daily pages to get our declination. Now, where you found the 14 for GHA, the 14th hour for GHA, you're going to keep on going over a little bit. You'll see declination. For 14, it'll be south 22 degrees, 46.6 minutes. Now, when you go all the way down on that table, you'll see a little d value. That is your declination correction. You're going to take what it says, 0.3 for us, and if it's increasing going to the, as you go up, it'll be a positive value. If it's decreasing going up, it'll be a negative value. In this case, it's a negative value. And then you have to go back to the increments and corrections page to find that correction. You just go to the same table that you did everything up here for minutes and seconds, the 30 table. And you're going to go all the way to the right to the little v and little d correction. You're going to find 0.3 and then write what is the correction right next to it, 0.2 for us. Since this was a negative value, this would be a negative value. A lot of people get that mixed up, and sometimes that correction is not even that big of a deal, but it's still part of the strip form, so you should do it. And all you're going to do is minus this 0.2 from the 46.6, making our total declination south 22 degrees, 46.4 minutes. That, we have our exact arguments to put down in here with the problem table, and we'll be referring to everything coming down here. Now it's asking for the exact arguments. We're going to actually get LHA, so I'll circle this one, our latitude, and our declination. And write them exactly what it says up here, down here. So LHA, 323 degrees, 14.4 minutes. Latitude, 36 degrees, 56.06. Now I'm going to take that 0.6 and just convert it to a decimal, making this 56.1 north. Write the north in because we're going to talk about it later. And the declination, south 22 degrees, 46.4 minutes. And the south there, write the south in because we need that when we go into the site reduction table. Have our exact arguments in. Now we're going to get the entering arguments. The entering arguments is just your degrees. You're going to take the minutes and seconds off and just write the degrees over here. So 323 degrees, 36 degrees, 22 degrees. Now we did that because this is what we're going to square off on the site reduction table to find our Z base or azimuth base. Now we pull out our handy site reduction table, pub 229. You can use pub 249 if you have it available, but I like using these ones right here. They don't need correction, and you don't need to update them. The aeronautical error slight reduction tables, they're good. They have a year on them, and they're good 4 years before that year and 4 years after that year. After that, you need to get new ones. But luckily for us, we get the quarterly CD, and it has this pub and the error slight reduction tables too. So you can use either one. Just know the orientation is a little bit different. For pub 229, the LHAs are at the top, and then you square off the latitudes and then the declination. So we find LHA 323, and then our latitude and declination. Notice that latitude is north and declination is south, meaning they are contrary to each other. And when you're looking at your slight reduction book, at the top, on the left side, you'll see same. If the declination and latitude were the same, you use that side. And the other side, you have contrary. Since they are different from each other, we're going to use a contrary side. Now, we're going to square off 36 degrees for latitude and 22 and we get 142.9. And we just write that in. All right. Now, Z tabulated. That is basically taking your entering arguments and going to the next highest one and square it off that way. For this, 323, 324 is the next highest LHA. So you'll go to the next highest LHA using 36 and 22. Square it off and do the same thing. We get 143.8. Go back to the LHA you just had. And now we're going to do the next highest latitude, which will be 37. Same page. Do 143.2. All right. Now staying on the same page, using 323 LHA, 36 for latitude. Now we're going to use 23 for declination, making it 143.5. Now, to keep your slight reduction book open and just set it to the side, because we're going to refer back to that when we do the conversion rule, when we get to it. Now that we have Z tabulated and Z base, we're going to pull out our calculator, and you're just going to find the differences. And it tells you exactly what to put in the calculator. Z tabulated minus Z base. Now it comes out negative, still put it as a negative, it's fine. So 143.8 minus 142.9, you get 0.9. All right, next, 143.2 minus 142.9, 0.3. And 143.5 minus 142.9, you get 0.6. Now that might be simple math for you. If it is, that's okay. But since I have the calculator handy, which most people do, just having a smartphone, wish I can tell that to my third grade teacher, just do it. That way you get the exact thing and you don't mess it up. Because one decimal over could be the reason you got the wrong answer. Now, I say that as well with rounding. Round if you need to. Now, if you're going to surf nav, I recommend do not round until you get to the end. So when we get these increments right here, the factor, if there's like 3 decimals, write in 3 decimals and use those 3 decimals. Because if you round here, it might be a bigger number by the end. Now, if you are just on your ship and you're trying to do celestial, I round because I've been doing it for a while. But if you don't want to, good on you. Don't round. It's up to you. But if you're a surf nav, do not round. So right now we're going to take our increments and divide them by 60. The increments are just the remaining from the exact arguments. And we're going to get that value as well. So we're going to take this 14.4 and divide that by 60. Divided by 60, you got 0.24. Now 56.1 divided by 60, 0.935. And now 46.4 divided by 60. 0.773. Now that we have the z difference and the z factor, this is telling us to multiply those together. It tells you exactly what to do. That's what's great about these strip forms. It tells you exactly what to do, so you shouldn't mess it up unless you get wrong information up here. Now we're going to take 0.9 times 0.24. 0.216. 0.3 times 0.935. 0.28. And then 0.6 times 0.773. 0.46. Now we have the correction, and this is the total correction resist. That's telling us to add them all together. Now, if you were to get a negative number, you would just subtract it from the already positive value you have. So 0.216 plus 0.28 plus 0.46, we got 0.956. Got our total correction. That is fairly close to just 1 degree. But like I said, don't round until you get to the end, or don't round at all. The bottom part, this is the final part we're getting into. It's asking for Z base. Just taking your Z base and put it down here. Now it's asking for the correction that we got, which is just this total correction. It's a positive value, so you'll be right here. 0.9. All right. Z is basically adding these two together. You can use your calculator because you have it. 142.9 plus 0.956. Now, this is where I would round. 143.8. All right. Now, the conversion rule. If you look at the site reduction table at the top for northern latitudes, it will tell you if your LHA is greater than 180. If your LHA is greater than 180, Z equals Zn. If your LHA is below 180, you'll take 360 minus your Z, and that will equal Zn. Now, since our LHA is well over 180, there is no conversion rule. RZ equals Zn. And just write it in. Okay, almost done. Now it's asking for the observed. We wrote down up here what we observed. We observed 142.8 degrees true. 142.8 degrees true. Now there's a saying, if the gyro is best, it's west. If the gyro is least, it's east. When it's talking about the gyro, it's talking about what you observed. Whatever your gyro compass said. Our gyro compass said 142.8. 143.8 is higher than that, so the gyro is least, telling us it is an east value. It is 1 degree, and that's your gyro error. Our gyro error is 1 degree east based off all this information. Now, you can go in Stella. Stella is pretty simple. All you need is a position, a time, and the date you did it, and then the site. Basically, everything from GMT up. It already has a Nautical Almanac embedded in it and the site reduction tables. So putting in this information is not needed. That's why Stella is a very great tool, but I always say don't rely on one information. Same thing with VMS or Nectus. That stuff is a computer. Computers are awesome. You know, get it down right down to the second or the minute point degree, but it's valuable and it will stop. And I say that because ships lose power. Ships have problems. Not all the ships, a lot of our great ships are great. But to know this information, you can't say you can't do a day's work of navigation. That's all I have to say about that. This is Azimuth with the Sun. If you like this content, give it a like, consider subscribing to the chart table.